All right, welcome everyone. This explainer is designed especially for all you teachers and educators out there. We're going to dive into a really fascinating question. How on earth do computers understand our language? All its messiness and complexity? And for this, we'll be leaning on the great research of Dr. Sudheendra S G.
Okay, so let's jump right in. The very first thing we need to wrap our heads around is just how different machine language is from human language. And trust me, it's like they're from two different planets.
And this slide, wow, it just lays out the whole problem perfectly, doesn't it? Over on the left, you've got programming language. It has to be perfect. One wrong symbol, and the whole thing just fails. But then look at the right. Human language. I saw her duck. I mean, what does that even mean? Did I see her pet bird? Or did I literally see her duck down to avoid something? That ambiguity? That's the beauty of our language, but it is an absolute nightmare for a computer.
So, how do we solve this? Well, that's where this amazing field called natural language processing, or NLP for short, comes into play. It's basically the bridge between our messy, contextual world and the computer's super precise black and white world of ones and zeros. It's the translator that makes communication possible.
Okay, to really get how this bridge gets built, let's follow a super common question on its journey. Something your students, or let's be honest, you probably say all the time. Where's the nearest pizza? We're going to trace it from start to finish.
So, step one. Before a computer can understand anything, it first has to, well, hear it, and then it has to chop up those sounds into little pieces it can actually work with.
It's interesting, it doesn't start with words. It starts with pure sound. Your voice creates sound waves, and the computer turns those waves into a visual picture, called a spectrogram. It's like a photograph of your voice. And from that picture, it can start to pick out the basic building blocks of sound, what linguists call phonemes.
All right, once it's got the sounds figured out and turned into text, the computer does something called tokenization. Now that sounds super technical, but it's really not. It just means it's breaking the sentence down into a list of individual items. Every single word, and yep, even the punctuation, gets separated out. They each become their own little token.
Okay, so now we have a list of tokens. The next puzzle is to figure out what each token is. This is called part-of-speech tagging. It's like labeling everything. This is a noun, this is a verb, this is an adjective. But think about a word like rose. Is it a verb like the sun rose, or is it a noun like the flower? Context is everything, and this is one of the first big hurdles the machine has to clear. Okay, so we've got words, we've got labels. Now for the really cool part. How does the computer figure out how all these pieces fit together? We're talking about grammar, the very structure of the sentence. The way it does this is by building something called a parse tree. The best way to think about it is like a sentence diagram or a grammatical blueprint. It's a map that shows how the words connect to form phrases and how those phrases connect to create the whole idea. But, and this is a huge but, what if a sentence can have more than one blueprint? What if it's grammatically ambiguous? That's when things get really, really interesting, because the same exact words can mean totally different things. So in one version of the blueprint, the man is the one with the telescope. The phrase with a telescope is attached to man. Simple enough. He has a telescope, and I saw him. But in a totally different blueprint, I'm the one with the telescope. The phrase with a telescope is attached to how I saw. It's my tool. And boom, two completely different meanings from the exact same words. This is a perfect example of why getting the structure right is everything for the machine to get the meaning right. Okay, so the computer has the grammar down, but that's just understanding what was said. The next giant leap is figuring out what you want. This is where we move from just listening to actually doing something. And the way it does this is by looking for two key things. First, what's the overall goal here? That's called the intent. And second, what are the specific details I need to pull this off? Those are called the slots.
And this table here, this is where the magic really happens. Look at our pizza question. Our messy human phrase gets turned into this beautifully clean, organized command. The intent, it's find place. And what are the slots, the details? Well, the food is pizza, and the constraint is nearest. You see, it's no longer a question, it's an actionable order. This is the real aha moment for the whole system.
Now what about when the computer needs to talk back? Well, it basically just runs this whole process in reverse. It starts with the text of its answer, it figures out the basic sounds for those words, then, and this is super important for making it sound human, it generates the prosody. That's all the rhythm and intonation, what stops it from sounding like a flat robot?
All of that gets turned into another one of those sound pictures, a spectrogram, which is then fed into a vocoder that synthesizes the final audio that comes out of your speaker.
Okay, we've spent a lot of time on the how, but now we need to shift gears and talk about something that, as educators, is arguably the most important piece of the puzzle, the ethics of it all.
And this is a conversation we absolutely must have with our students. These tools, they aren't neutral. They learn from the vast amounts of human text and speech we've put out there, which means they can pick up and even amplify our worst biases. We're talking about huge questions around privacy with always-on devices, what it really means to give consent, and how this tech could be misused. This isn't just a tech topic. It's a civics topic.
Dr. Sudheendra S G's research puts it perfectly here. That whole journey we just traced, from words to structure to meaning to action, it creates incredibly powerful tools. And, with great power comes great responsibility. We have to be thoughtful and ethical about how we use them. So this is the thought I want to leave you with, to take back to your schools and your students. Our role here isn't just to be tour guides for the technology, it's to raise a generation of critical thinkers. We need to teach them not just how to use these tools, but how to question them, to challenge them, and ultimately, how to be the architects of a better, more responsible future for this technology.